So completing the square is a technique that will always get us all of the solutions to a quadratic equation, assuming there are any solutions. But it's a kind of tedious process. And after we've done it a few times, we start to notice that it's actually the same every time. So instead of completing the square every time we want to solve a quadratic equation, we can go through the process once and for all, leaving the coefficients as variables. And then that will give us a formula that we can use to just solve any quadratic equation that we want to. So that's what we're going to do here. We have a generic quadratic equation in standard form. So A, B, and C are the coefficients in this order. And we're going to go through and thinking of A, B, and C now as known numbers, we're going to solve this equation by completing the square and see what formula that gives us in terms of A, B, and C for the solutions to an equation like this. So to complete the square, we need to get x squared plus something times x on one side. So we need to get rid of the A and the C on the left. First, we'll subtract C on both sides. So we'll have ax squared plus bx equals negative c. Then we'll divide both sides by a. So we'll have x squared plus b over a times x equals negative c over a. So I've just gone through and divided each term by a. That did assume that a is not 0, but if a is 0, we don't have a quadratic equation. So that's a safe assumption. Okay, now it's time to complete the square. And I'm going to do that off to the side here. So I'll have x squared plus b over a times x plus something equals x plus something squared. Going down to my square here, I've got x squared in the big square in the top left. And then for my two small rectangles, I want to split my b over a equally between those. So I'll say b over a divided by 2. That's b over a times a half. That's b over 2a. So each of these little rectangles will have b over 2a times x. So the square, the big square, is x by x. And then the little rectangles have b over 2a on each side, which means the little square down in the corner here, its sides will be b over 2a times b over 2a. So b times b is b squared. 2a times 2a is 4a squared. So b squared over 4a squared. My missing piece, the little square in the bottom right, is b squared over 4a squared. And I get that perfect square trinomial by having x plus b over 2a and squaring it. Okay, so I can take that information back and complete the square. I've got x squared plus b over a times x. And now I'm going to add b squared over 4a squared. And that equals negative c over a plus b squared over 4a squared. Okay, now I'm going to take a minute and simplify that stuff on the right-hand side. Right, so I'm going to write b squared over 4a squared first, minus, I've got c over a. To get a common denominator, I want to multiply that a by 4 and another a, which means I need to multiply c by 4 and another a. So actually subtracting those fractions, I'll have b squared minus 4 times a times c, and that's all over 4a squared. And now I've completed the square, so that whole thing is equal to x plus b over 2a all squared. Okay, so now I've completed the square. My next move is to use the square root property. So x plus b over 2a is going to be equal to plus or minus the square root of b squared minus 4ac all over 4a squared. And now I think we can simplify that square root a little bit. Let's see what we can do there. We can certainly split up the numerator and denominator. So we'll have plus or minus the square root of b squared minus 4ac all over the square root of 4a squared. Oh, but I think 4a squared is a perfect square. So I think we'll just have plus or minus the square root of b squared minus 4ac all over the square root of 4 is 2. The square root of a squared is a. Now, what I just told you about the square root of a squared is a fib. Thinking about it, the square root of a squared is always positive, so it ends up being the absolute value of a. But we've got this plus or minus. So if a happens to be negative, that just switches which is plus and which is minus, which doesn't matter. So now we've simplified our square root, right? We've got subtraction inside the square root in the numerator. There's nothing we can do with that. We're just left with x plus b over 2a equals plus or minus the square root over 2a. And now we can finish solving, right? We'll subtract b over 2a on both sides. X equals negative b over 2a plus or minus the square root b squared minus 4ac all over 2a. And those have the same denominator, so we can combine them. And we're left with x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And that formula is the quadratic formula, which we see here. The solutions to a quadratic equation are given by the formula, the opposite of b plus or minus the square root b squared minus 4ac all over 2a. And now we don't need to go through that process every time. We can just remember this formula and use it anytime we want to find a solution to a quadratic equation.